This is part one of chapter 2.2 video lectures. I'm looking at your note sheets you should have that go along with chapter 2.2. We're going to be talking about the second derivative test and how we use that to find max and minimum values, similar to what we did in chapter 2.1. So here's a quick introduction to that. To do that, I want to show you some pictures here. And so what we do in chapter 2.2 is talk about concavity. We ask if a graph is concave up or if it's concave down. Here's a picture of a graph that we would say is concave up. And an analogy we use, does the graph hold water? And so that's the analogy. This is concave up compared to this graph here, which is concave down. So important words we're going to talk about are concave up and concave down. Here's a graph that's concave down, and it does not hold water. So if you put water on top of this graph, it would fall out, or if you put into it, it would fall out. So that's a concave down example. And then here's an example of a graph being both concave up and down. And so you can see here it's concave down here, and then here you could see it's concave up. So it changes its concavity. And so somewhere here, about this line here, you would see where it would be holding water now. Here it would be falling out here. And then we will look at that. And so here's an example here. Put the green dot where the function is concave up. Concave, where it says concave down with the derivative greater than 0. And so in this case here, I have concave up in this area here, over here, and the derivative is positive. It's going up. And then here's an example. Put the green dot where it's concave down. So this is concave down, and the derivative negative here, and then it's negative here because what we can see is here you're going to have the slope is negative. And so what we're getting at is, you see there's a maximum point here, and that happens when the derivative, remember, goes from positive to negative, and then you see it's a maximum and it's concave down. Next point here, put the green point where on the function where it's concave up and the derivative is positive. So this is concave up over here, and the derivative is positive since there would be a positive slope here. Put the green dot where it's concave up and the derivative is negative, and that would be on this side here. It's concave up, it's holding water, but the derivative is negative, the slope is negative. And when that happens, you have a concave up and the derivative goes from negative to positive, you have a minimum value. And that's what we're going to be learning in this section here. At the maximum, is the function concave up or concave down? So right here at a maximum, that would be concave down here. Can't hold the water here. So you have a maximum when it's concave down. At the minimum here, is it concave up or concave down? And so looking at this here, it's concave down. Concave up here. And you have a minimum. And so that's an important point on this here. The next piece would be what we call an inflection point. And so let's look at that, the next screen. And so the next thing we talk about is inflection point. That's the terminology we use. An inflection point is where it changes from concave up to concave down. So that's a nice definition to have. An inflection point occurs where there's a change in concavity. And so we'll be using that language there. Let's go look at an example here. Place the green dot where you think it changes concavity. So if this is concave down, concave down, concave down, and then right here somewhere it holds water, but then right here it changes concavity. Now it's concave up. It's hard to look at, again, hard to pick up the first time, but we have a change of concavity. It's concave down, down, and then now it's up. It holds water here, but here it can't hold water. And so zooming in on that, again, we're looking at a change of concavity or a point of inflection. That's where the concavity changes. And so the connection we have in this section is that the concavity changes when we have a relationship with the second derivative. And so here, the one in red is the function. The second derivative is in green. Where is the second derivative equal to 0? It looks like at -1 right here, the second derivative. And what we're going to point to is that where the second derivative equals 0. Now in 2.1, we set the first derivative equal to 0. In 2.2, we're going to set the second derivative equal to 0. And where it's equal to 0, this is where you're going to have your point of inflection. And so looking at it here, the red function is the original, the purple is the second derivative. Place the orange dot where the second derivative is equal to 0, right here. And then we're going to place the blue dot where there's a point of inflection, which is right here. The graph changes concavity right there. Sorry, right there. And so what we're looking at is that when the second derivative is equal to 0, we have a change of concavity, the point of inflection. And so that's what we want to look at in terms of this situation too. So here we go again. Where is the second derivative equal to 0? Right there. That's called a critical point. It's like in 2.1. And you see it's concave. We have concave up. Sorry, concave down here. It's kind of bent this way here. And then now it changes concavity. Now it's bent this way here. And so this is where you would see a point of inflection, where it changes concavity or where the second derivative equals 0. And we can continue to do that, but this is what you have here as we go through that. I'm going to attach this while you're looking at the video, so you can take a look at this here. But again, the second derivative equals 0 here, and then we have a point of inflection approximately here where it changes concavity. And so then you can take a look that we have that relationship between the point of inflection and where the second derivative equals 0. So that's our introduction for 2.2.